Assalamualaikum warahmatullahi wabarakatuh. My name is Nina Amira binti Amal Khairus. My number metric is B092110092, and I'll be explaining about the introduction of pin on disk. So basically, what is pin on disk? So pin on disk is a test that we have to perform to test the simulation of wear, friction, and also lubrication using Tribology tester. So Tribology tester is designed to test planar base materials against a counterbody under sliding conditions. So the counterbody is pressed on the rotating base material by a defined load. So that's all from me. Thank you.
Assalamualaikum, my name is Siti Nazira Kina binti Mauta, and my metric number is B0922100472. I will present about the objective of this lab pin on disk. First one is to investigate the friction and wear behavior of material bearings. Second is to analyze the friction behavior under varying conditions such as different loads and sliding speeds. And the last one is to characterize the tribological properties of materials such as wear resistant or coefficient of friction.
Hi, Assalamualaikum. My name is Nofarhana binti Cik Muhammad Harizam, metric number B0922100434. I will explain about the function pin on the disk. So, what the function pin on the disk? Friction and wear, typically wear rates and wear resistant characterization of material is typically performed using various steps of the tribometer, while pin on the disk test being probably one of the most common. Tribometers can be used to investigate the friction and wear behavior of material bearings. A test material, e.g. a steel ball or a pin, is moved on a circular path over the specimen with a defined standard force approximately 5 Newton pin on disk. During the test, the friction force or the coefficient of friction is measured continuously. The wear is subsequently determined by measuring the wear drag and the abrasion of the test specimen.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fahmi bin Musa. My matrix numbers is B09211047 from BMMM section 2. Okay. Right now, I would like to present about procedure or methodology of lab pin on disk. Alright, before I go through explain about procedure and methodology, I would like to explain first difference within experiment 1 and experiment 2. For experiment 1, we use the constant load that is 10 Newton and 20 Newton. But for experiment 2, we use constant speed at 40 RPM and 160 RPM. Right now I would like to explain about the experiment 1 first. That is, we use the constant load for 10 Newton and 20 Newton. Okay, before we switch on the machine, we need to insert the brass pin into the pin holder. Next, after we insert the brass pin, load the weight at the end of the loading arm. Okay, that is you use 10 Newton or you want to use 20 Newton for the experiment. Depends on what data you need for 10 Newton or 20 Newton. Okay, after we attach the brass pin and load weight, lowering the loading arm until it become touch on the surface of the disc. Okay, after that we need to add on a little bit lubricant into the disc. Right, after we add on a little bit lubricant onto the surface of the disc, okay, we can switch on the machine and wait for a while to make sure the machine was start up properly. Okay, next, after the machine was start up properly, you can set the speed within 10 RPM, 14 RPM, 18 RPM, 100 RPM, and so on lah. That has been given in the lab sheet. After the data was been taken, lastly, you need to change the weight load to 20 Newton, and you need to read the measure friction for each speed within 10 Newton, 40 Newton, 80 Newton, and so on, and record the data on the lab sheet. Right now I would like to explain about experiment 2, but the methodology or procedure for experiment 2, same goes to experiment 1. That is, insert the brass pin in the holder and load the weight and lowering the arm, lowering the loading arm until attached on the surface pin. Surface disc, and add on the lubricant. Switch on the machine. Okay, but the difference for experiment 1 and experiment 2 is load, constant load and constant RPM. For the experiment 1, constant load, that is 10 Newton and 20 Newton. For experiment 2, constant speed at 40 RPM and 160 RPM. Alright, for the experiment 2, like we know, that is constant speed at 40 RPM and 160 RPM. But the changes for the experiment is only the load weight. Okay, we start with suspended at 10 Newton load and 50 Newton, 20 Newton, 25 Newton, 30 Newton and 40 Newton. Okay, so if you want to add on the load, we don't need to switch off the machine and start from the first procedure. We just add on while the machine was running. Okay, so the observer need to record the data after we add on the load weight on the at the end of the loading arm. Alright, that's all from me. I will pass to next presenter. Thank you.
Assalamualaikum and hi, my name is Muhammad Afiq Ashraf bin Rosdi. My memory number B0921101167. Now I will explain about the result. So as we can see on the poster, that's our result that we collect from the experiment. So based on the result on experiment 1, we are using a constant weight, which is 10 Newton and 20 Newton. So for this experiment, we just change the speed starting from 10 RPM until end it's with 200 RPM. So for the 10 Newton weight, we can see that by increasing the speed, it will increase the friction reading, and then but it does not increase too much. It's just increase a little bit. So for me, I think it's not effect on friction reading. And then by using the 20 Newton weight, we can see the result will increase by increasing the speed, and then the friction reading will decrease. Okay, next let's explain about the experiment 2 result. The experiment 2 using a constant speed, which is 40 RPM and 160 RPM, but by changing their weight starting from 10 Newton ended with 40 Newton. So the results shown that it's increased from time to time in friction reading. So we can conclude that this result happened because of some error, maybe from the systematic error. So we can minimize it by routinely calibrate equipment, or can compare it values against theory or standards. That's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. I will give the conclusion after we have completed the experiment. From this experiment, we can conclude that based on experiment 1, the friction reading increased with the speed with the load was 10 Newton. Second, the friction decreased with the speed when the load was 30 Newton. Okay, for experiment 2, the friction increased with load at constant speed. Based on the results, we can conclude that the friction between two surfaces is affected by both speed and load. The friction is higher when the load is higher, and the third one, the friction is lower when the speed is higher. This experiment has achieved its objective of investigating the effects of speed and load on friction. The results of the experiment can be used to improve the design of machine and devices that involve friction, such as gear, bearings, and brakes. That's all from me. Thank you.